Right, let's get started again. So this is kind of like a special episode because yesterday the streaming went very badly, partly because my internet connection was horrible, and so I did some testing afterwards, like figured out why is the frame rate would dropped and the connection is not good, and I discovered that actually my VPN is slowing down the internet speed, and now it should be up to full speed. I've done some speed test before I stream, so I hope this is fine. Even though like from my monitor, I'm still seeing some lag there, but I hope that's normal lag. Um, yeah, so all the traumas, and also like I was very tired yesterday because I just finished Python and I didn't get enough rest. So hopefully today is gonna be a better day for the streaming, and hopefully the tutorials like better prepare. I've revision like done some changes to my slices because I figured out that like I am missing some content there and like here and there and try to improve it a little bit. I miss talking about scikit-learn and how to use it and all this stuff. So if you have came across the recording yesterday, forget about it. If you have watched yesterday and you come back, thank you so much, and I hope that this will be better. And again, like please say hi in the chat. Ask any questions. I really love seeing people say hi in the chat. Actually, just that really make me happy. That I feel like people are watching. I'm not just like making this tutorial only for myself. Um, yeah, so okay, so I was just like as if yesterday didn't happen and we are still streaming for the first time. And for people who come in like the newcomers today watching the live stream, this is actually scheduled every Monday 5 p.m. UK time, but because of the recording failed yesterday, basically the video is not usable. I downloaded it and then look at it, it's like lagging so much that you would have problems seeing what I'm showing. So I decided to redo it. Hopefully this time is better. If the streaming still doesn't go well, I will have to record it, without streaming and then upload it as a video. But let's hope that it's not that bad. And yeah, I'm still very nervous because sometimes, yeah, it's still showing some like red on my computer saying some frame is dropped, but it's not as bad as yesterday. So hopefully that's better. Okay, so let's get started. Um, so what is logistic regression? So last week we talked about a linear regression. Basically, we have a bunch of data that you collected, and we want to find a model, a line that could that could feed. We mentioned the term feed. So basically, we find a model, a line that matches all this dot. Why we love a line? Either it's a straight line or it's well sometimes not a straight line. Like today's case, I will show you later how it looks like. Why we want to use a line to feed the data? Well, reason being, like a line is a mathematical model, so you can basically have any input. So like here you see this x1, x2, x3. So you have input, which are the features that is known, and then you could go through the model. So here it's like go through this diamond thing, and then you can have a result that you can predict. So in logistic regression, your prediction will be um, either one or the other. So it's like happy or sad. But in linear regression, the result will be a value, a number that could tell you something. So that's why we want to do a modeling on the data. We want to feed the data. That's why we do machine learning. This is how we this is why machine learning is so powerful. Is that if we got enough example of the data, we could you can use a machine to find out a solution of it, find out the relations between things. And when we have something that we don't know, from what we get the input, the x, and then we could know the answer y due to the previous experience of all the data that we collected. Um, so uh, so that's what we're gonna do. So today, logistic regression, like I said, the prediction is gonna be 0 over 0, 1, so one or the other. So this is how, you know, um, you figured out, oh, I should use logistic regression when you have something, the outcome of it is either one or the other. So some example would be, predict whether an email is a spam. So either it's a spam or it's not spam. So it's either one or the other. So the other is that whether tumor is malignant, so it's whether it's a good tumor or a bad tumor, whether you should worry or not. So again, um, 0 or 1 here. And or the other example that I can think of is like whether a customer will leave. So it's like again, like leave or not leave. So it's useful in when predicting churn, churn predictions. Um, so um, so what does data look like if we plot it? So imagine we have a bunch of x's, or to simplify it, so we can plot it in a 2D graph. We have an x, and the y outcome would be either 0 or 1. So how does it look like? So I have already did it before, so it's not a brand new notebook. I have clear out all the data and restart the kernel. So here you can see that. I hope you can see it. I can make it bigger. Oh, by the way, I put myself on the right hand side. If you have watched my previous video, I am usually on the left hand side, and also the image was the other way around. So now I flipped it. So when I point here, then actually I'm like pointing, to the right direction. So sometimes like when I watch some of my videos, I was pointing in the wrong direction, and it's super funny. Um, so also like the reason why I put myself on the right hand side is that I realized that I cover some of the code. So I think it's better if I put myself here and my logo go on the top left. Sometimes I forgot to put my logo in because I did some recording for EuroPython, and I took down my logo and I forgot to put it back in. So now it's there, and I hope this is better. Okay, and so yeah, okay, so this data that we have is a bunch of x. So I'm thinking like this, you can interpret this as, for example, I have how many capital letters or how many spam words. So you have a definition of spam word, for example. You have so if you have all these words that you think that is a spam, then you would calculate them, and then or just like how many all cap words that you can find, right? Okay, so maybe in a normal letter, email, or that you send to your friend or your colleague, that is like all cap would be just like 1 or 2 or none, because you just like maybe the only very important word, then you would be all cap. Actually, I think all cap is a little bit rude most of the time. But if you like, for example, you're emailing your friends, it's a little bit jokey, then that's fine. But in a spam email, maybe there's like loads of all cap words. Okay, so this is the all cap words count, let's say, and y, the result will be whether it's a spam or not. So 0 is not spam, 1 is spam. Okay, so so this is of course I fabricated it, but actually you can do something similar to that. If you have a bunch of spam mails sitting in your spam folder, you can actually do something similar. You get something fairly close to this example here. Of course, you will have more than 6. You would need much more than that, but I'm just showing an example here. So so I won't make such a big data set. This is a tiny nano small data set. Okay. So let's visualize it. So this is the bouquet. I use bouquet flew out because I would try to make another slider game, but I don't think I would have time to do it because actually I realized that is you have to use SciPy to plot a smooth curve in bouquet, so it will take a lot of time. So I won't do it on stream. So yeah. Mm. So you see that this is the data that we plot for the example data set there. And you can see that like it's actually just clustered into two separate cluster. I would say one is like y is 1, right? So those are there, and then a bunch of they would be like 0. So if you want to fit aligned fluid, so you'd be like, okay, that's easy if something below 10, let's say, right? So I just draw a straight line at 0, and for those like above 15, I would just like draw a straight line at 1 across, horizontally. But well, it's not a continuous line. It's broken somewhere. You have to switch somewhere, right? So it's difficult to fit a straight line on it, and it's no way that any linear regression could fit this model very well. Because last time, remember, like we only have 5 dots, and we try to find lines to go through it. It's kind of work. It's not very good, but you get the idea, because like just a bunch of line. Oh, by the way, I should actually show you what I did last time, because this is because since last week I've improved it and now it's actually working. So let me do a run all. That's the easiest. So I'll do run all cell and yeah. So this is the game that I've done. So let me make it smaller again so you can see the whole thing. So um yeah, you can see that we have a bunch of dots, and then we try to find a line to go through it. Or you can see that I've changed it actually last time, yesterday to a root mean square error. So now you can see that like it's not very good still. We try to like minimize it as much as possible, but it's still not perfect. And imagine like you try to do the same thing with these data, right? It's not going to be well. Yeah, you could try, but it's not going to be well. So we need another line to go through all these dots. So what we should do, like, because like I said before, you can draw two straight line, like below and above, but it's broken. There's no way, like, how do you connect them? And also in mathematics, we like lines that is continuous and also differentiable, which means that there's no sharp turns. Um, so what? Go back to the slides. So what we can find is that okay. So yeah, this is basically just what I said. Like data are not forming in line, and x and y's are not actually look linear. It's not close to a line, and there's no way to use a straight line to feed the data. We need something else. So this is what we're gonna use. This is called a sigmoid function. So it's a bit small, but like this, it's 1 over 1 plus e to the power of minus t. So this is the sigmoid function. And so yeah, the x-axis is called t-axis here, but they are the same thing. So yeah, e is the exponent. I hope that you already have understanding of these mathematics. So yeah, I don't know how far I should go into the details of the mathematics sometimes, because I don't want to put too much effort into explaining the math. I just want to go through the idea so you have an idea. And I assume that people watching, they are coders or they're interested to be doing some coding. So yeah, I would go through enough math that you understand the idea, but won't go to too much detail of, like, for example, writing like 10 lines of math to prove it. Yeah, so this is how, like, this is the sigmoid function and the mathematical equation is there. Okay, so for the sigmoid function, if we find the right t-axis, because remember, like for our data, the middle of this like kind of intersection of 0 and 1 is not at 0 because we have nothing that is negative, right? So our graph is more like it's shifted to the the whole sigmoid graph needs to be shifted to the right hand side for maybe 10 or 12. So the middle is kind of like at the like kind of 10 or 12 here in the middle. So we have to shift the graph horizontally. Vertically, we don't have to shift the graph because, like, well, it's 0 or 1. If it's not 0 or 1 for some reason, you just have to rescale it. Then you will shift it. But most of the case, then you don't have to, because we're detecting two results and we just name one to be 1 and the other to be 0. So yeah, this is the sigmoid function. So and we have to find, yeah, so the question now becomes like, how we gotta find this, how we gotta find this shift to make it right, so the sigmoid function can explain our data. It's too difficult because last time we can actually use mathematical way to find a solution, but it's not always the case. It's easy enough to do it on a straight line um, because we straight line is very very easy. Everything's linear. You can just easily find like the minimum of it. It's not always the case. That's why we have to do machine learning, because we can do it programmatically. Okay. So I want to go to the next slide. So yeah, remember in linear regression, so last time actually what we did is that instead of doing it mathematically, like grab a piece of paper and a pen and write down mathematical equations and use your high school math to solve it. We do it with our program. We do it with our interactive slider there to slide it around and try to find the good the good B and A, the slope and the intercept to so that the error is small, so the root mean square error is small. So we could do that also with the computer, but we need to know. Well, for linear regression, it's quite easy. We have already done it. We could minimize the root mean square error of it because root mean square error basically is the mean of all the errors, right? So we want to minimize that. So yeah, so this is the equation for root mean square error. I put it right this time, and yeah, so it actually is a measure of how far off the line is. So if your line is very far off, let's say here, if I put it like very far off, right, like this. Wow, this is so off, like it's not even including. So you can see that root mean square error is super big. It's 3.2, 3.27, so it's like really big. But if the line is like more or less kind of matching the thing, the last time I forgot what's the perfect. So for example, this one is, well, by eyeballing it, you can see it's a better fit. It's only 0.29, so it's like, so it's like 3 less than the previous one. So the lower this root mean square error, the better fit the line is. So we need some measurement to see like how wrong your model, your line is from the training data that you have. So I explained training data and testing data last time. So you can go back and check last week's video. So the data that we use to find that right line to feed the graph, to feed the model is called the training data. So we need a measurement to see how far off your model is from the training data. So this is the cost function. So this is actually what you measure. So in the linear regression is just root mean square error. It's quite straightforward. But in our logistic regression, then this is slightly different. So so by the way, this is the equation that I want to make the slider game for the logistic equation. So you can actually change the B0 and B1. So because like I said, we have to shift the x-axis, shift the left and right, and also maybe squish it a little bit sometimes to fit it. So yeah, so this is how I can actually put it into the game, the slider game. But it's not very easy because I have to make a curve, in the port. So I would do it off the screen. And so also we have a threshold that, if with this equation give me a greater than 0.5, then the prediction is 1. But otherwise, the prediction, is 0. So it's anything less than 0.5 or equal to 0.5 is 0. Okay. So cost function. So go back to cost function. That what is the measurement to measure how off your model is? So there's actually a way to measure it, but we have to break it down into 2 cases, okay? So the first case is that if the truth, if the data, the answer is 1, and your prediction, of course your prediction is perfect when your prediction is 1, right? Because well, it's supposed to be 1 and you give the answer is 1, so you're correct. So we want this cost function to be reaching, so we are looking at the left hand side right here. So we want this cost function to be reaching 0 when I have a prediction is 1. So the closer to 1, the lower the cost function, because it's more correct. And of course, if the prediction is 0, that's totally off because, well, you're predicting the opposite, so that's wrong. So that's why we have this log function here. So log function, actually, if you know that, is basically like this, okay, like the one on the left. So that applies to the cases when the correct answer is 1. But the thing is flipped in reverse when the answer is 0. You want the prediction to be 0, and that's the correct answer. So the cost function should be 0 when your prediction is 0, while the answer is 0. So you can see that we are talking about the right-hand side here. Now that the right-hand side here shows that is actually um, uh, is minus. So actually, the right hand side is the log function. So log function is like the one that shoot to the sky. So the bigger it is, the bigger it goes there. So right. So we want to we want to have it like, so there's actually two cases. So that's why the log loss here, the cost function actually is the sum of both cases, but there's a trick there. So you can see that if y equals to 1, the second term there, 1 minus y, which is 1, is 0. So we have just log y, but it's minus there. Okay, so if you have y equal to 0, then the first one, it will become 0. So it's minus log 1 minus y dash. Okay, so this is how we use to. So we want to minimize that. So when it's minimized, then we will find the best fit of the graph. Okay, best fit of the graph. So I gotta use all this information to do the slider game. So when it's done, I would also upload it to the repo. So I would also show the repo at the end. I always forgot to put the repo in the last slide of the presentation. So yeah, I have to also put it in the presentation somehow. It's just my GitHub, and then you find legend of data. So that's the repo name. Okay, so we have around half an hour. So we could the last thing I want to show is to show how to do it with scikit-learn, because like I said, you have to minimize it and all these things. So well, you could do it like, again, use a for loop or use a search algorithm to find the best answer, but that's not the most optimized way to do it programmatically. Scikit-learn provide a very good way to do it programmatically. So let's have a look at it. So first of all, we have to switch back to our Jupyter notebook, not this one, that one. Okay. So yeah, so we have the scikit-learn documentation here is using this logistic regression. So what I'm going to do is that I will try to see if I can fit my my 6 dot of spam or not spam fake data in there, and just demonstrate how to do it. So, or I could just run this iris dataset, but I think, because I haven't illustrated iris dataset, I think it may not be the best best way to showcase it. So how about I just like import the thing from scikit-learn first. So I will import the linear model from, or it's not yeah, it's a linear model, but it's logistic regression. It's called linear model because it's it still involves some linear thing there. Remember the equation here. Yeah, this part is still linear. It's just like we add this like sigmoid function in here, so it's still a linear model, classified as a linear model, but it is the logistic regression. So so we don't have to load the iris data. We just use our data, and then we just like create this. So I would actually, oops, sorry, I pressed the wrong button. I don't like this. Okay, so I'll just copy this, and oh my god. Okay. Right, so I'll do it step by step actually. So I would put this separately. Okay, so I gotta do is like random state is 0. So yeah, I think that's like for when you run things multiple times, you want to make sure that, because it involves some randomization, and you want to, if you want to reproduce it exactly the same every time, so you want to set the random states, but that's not super important. We can just leave it as it. So CRF is the logistic regression here. So the data we want to feed will be this X and a Y in this DF. So what I gotta do is I just call a DF X and DF Y. So DF X dot values. Yeah, so I want to make sure that it's the NumPy a NumPy array instead of a series. So that's why I do this. Okay, and then this should be capital Y dot values. Okay, so this one should fit. And the last thing we want to do is to maybe. Yeah, we can show the predict result. Then we can predict something afterwards. We can also show the predict probabilities. We can test it out afterwards. So what else do they provide? So decision function. Oh, so there's a decision function as well. Um, yeah, right. Yeah, attributes. You can still find the coefficient of it, and yeah, true outcome and false outcomes, and because sometimes you have more than one classes. That's more like a general model, generalized model of the logistic regression. Because yeah, you can actually generalize it by changing the sigmoid function to do multiple classification. But we will try to cover it next time. Okay. So an intercept as well. So this is actually like very general for all these like linear models. Um, So yeah, how about like we just feed it and then we would just do some testing on it. Okay, so and oops, we got some error here. Oh yeah, it's the shape thing again. Okay, so I would do this. I would do this dot reshape. Okay. Yeah, that's the thing, cause like it's really doesn't like that. Yep. So it is fitted. So now if I do a prediction, um, so what we should predict? So we should give in an x that is equals to so how about we have a yeah, I have to have a numpy array, right? So I have to have a shape of uh, so how about I put in 5. So I have 5 all cap words, so what should it be? And oh, I don't have numpy. Okay. Yeah, I just gotta put in separately. So right. And oh yeah, all this shape is still a mess. Okay. I think the shape needs to be um, yeah, I don't know. I don't know, this shape thing is like really tripping me off. So what I gotta do is I just gonna do a reshape like this. Okay, so you give me a 0. So the prediction is no. So it's not a spam mail. So what about like uh 30? So it's 1, so it is a spam mail. So what about 15? 15 is still a spam mail. Okay. What about 10? 10 is not a spam mail, so we can still find the flush hole. It's actually more or less like at 12. Yeah, so this is like kind of what we expect, right? So it should be something between 10 and 12 is the flush hole of cutting it off, so you can see it from the graph. So it should be here that you kind of make a difference that whether it's a spam or not spam, okay? Yeah. So this is quite neat. Um, yeah. Do I have anything else that I could show? It's quite actually simple. This linear regression. Um, logistic regression. Sorry. We're doing class validation. Oh, there's cross validation. Oh, that's like, yeah, another topic for another time. So, yeah, actually, I don't have much to show. And, yeah, parameters. Yeah, I don't have much to show anymore. So I think I'll just end it. It's quite short. And, yeah, it's a remake of the whole episode yesterday. So I'll end it with scikit-learn. So I hope that you would use it. So a recap. So last time we did a linear regression using scikit-learn. Yeah, I'll just do a quick recap maybe to before I end it. So scikit-learn last time we did, well, we have the whole thing. Or maybe we can find an example that I do the illustration as well. Okay, so let me just find whether I can find an example at the end. So usually they have it at the end. Yes. Okay, so well, this is not really what it is it? Oh yeah, you can do a three-way classification. So next time we go into a um, multiple classes classification. So at that time we talk about that, or maybe do a little bit of these things. So yeah. So, oh, maybe the score. Can I get the score? And then mean accuracy. Okay. So predict proper. So actually, you have this predict probability. So maybe let me showcase this. This is new for this. So it's new for this classification type of model. So predict proper. What will be the difference between the predict proper and the predict here? So I will just put in the same thing here and see and then show you what the difference is. So yeah, you can see that actually there's a probability here now rather than giving you a answer. So this is giving you the answer whether it's a spam or not spam, right? So it's 0 or 1. But predict proper actually give you the probability of predicting it as a 0, which is 0.3, which is much lesser than this prediction of 1. So if we change it to, let's say, 10, 10 is more like difficult to decide. So it's like slightly towards the not spam, so that's why it's classified as not spam. So if you want a customized threshold, you can actually print out the probability and decide for yourself. This may be useful sometimes when you have imbalanced data to train, so it may be a little bit off, so you can actually set the threshold to, or maybe like in the use case, you want to be very, very sure that is a spam to maybe delete it automatically. So maybe you want to keep those that is a bit ambiguous one to still be not spam because you don't want to accidentally delete a useful email. So yeah, I don't know whether you can, for this one, you can set the threshold, the custom threshold. Maybe you can do it. Let's see. Yeah, you can set different weight and penalty. Well, yeah, those are the L1 and L2. Yeah, I suddenly forgot. Like, yeah, those L1 and L2 penalization thingy. So custom state. Yeah, it doesn't allow you to set. You can use it in the multiple classes as well. Yeah, it doesn't let you to set a customized flush hole. So maybe you can just like print out the probability and decide whether it's a spam or not spam yourself. So yeah, so that's the predict probability here for you. Yeah, I think that's it for today. Sorry that is short because I have to record it twice. I have to do this twice actually because I did it yesterday and it was not well. And I'm still a bit worried that the recording today is not very well because from my screen, it's still a lot of frame rate is dropped. A lot of frames are dropped, so the frame rate is horrible. So I don't want to invest too much time in it in case like it turns out to be rubbish again. So I would really want to cry. Um, so yeah, that's it. And yeah, I should really have to put my link to the repo here. So okay, last thing that I do here. So sorry, I keep saying last thing. So last thing that I want to do here, maybe come here and go to my GitHub repo, github.com. That's my GitHub repo, and I will put my link there, so I won't forget. So repositories, and yeah, so it should be the legend of data. Legend of data, where is it? Oh, that's strange. I overlooked it. It should not be that back. Yeah, legend data. So I try to keep the name as short as possible. So yeah, this is the link to the repo. So I should really put it here somewhere. Okay, I will do it when I cut, So thank you so much for sitting through this. And sorry about yesterday. I was not very happy and like the computer is not very well. I hope today is better. I hope that, the internet is better. I did the test before. It says my internet is very fast, but I'm not sure because like still got a lot of frame rate drop. But I hope it's better than yesterday and I can use this video. So thank you so much for watching and I'll see you. Oh, hello. Someone say hi before I go. So call Matt. Call Mert. Yeah. Oh, the reshape function. Okay, before I go, I should really explain it. So reshape function actually is in NumPy. So yeah, BumPy. No. Okay, so luckily I just saw your message before I go. Okay, so NumPy, so reshape. So yeah, NumPy is actually like a library that lets you deal with the array. So let me make this bigger. So hope you can see it. So yeah, actually like is reshape is just like let you to take because an array because NumPy deal with multiple dimensional array. So it could be multiple dimension, but I'm using 2 by 2 as an example here. It's easier to visualize in your head. So it's 2 by 2, and sometimes you want to take it, you want to flatten it. So you want to make, instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, you want it to be 1, 2, 3, 4, 5, 6, 7, 8, 9, or you want it to be 1, 2, 3, 4, 5. Yeah, it was difficult, but like you want to flatten it, or the other way around. You have a bunch of numbers. Let's say 1, 2, 3, 4, 5, 6, 7, 8. You want it to become 1, 2, 3, 4, 5, 6, 7, 5, 6, 7, 8. Then you do reshape. So you make you to rearrange your array into a different shape. So sometimes it's useful to because when in scikit-learn it wants you to have the last dimension to be 1. So you see that I did this -1 1 there. So yeah, -1 1 there, which means that -1 means that, oh, this one I don't care. You just go with it. If I have to be 8, it will be 8. If it has to be 10, it will be 10. So 1 means that the last dimension need to be 1. So basically what it says is that before I have an array of, let's say, so I think the problem comes in because I was having this, a series from pandas. So basically, it's an array that is flattened like this. But in scikit-learn, it's like, no, you have to be flattened like this as a column instead of just like one there. So what you have to do is actually so before it was just like a 1D array that is like, oh, a bunch of series, and now scikit-learn is like, no, you have to make it a 2D array. It's like, let's say you have 10 data point here. It's like you have to make it a 10 1 array. So it's like 10 and 1, so it's like a column. So yeah, so that's why it's complaining, and you have to reshape it. I don't want to think too much about it. That's why I just copy the prompt and put it there. So that's why I do that, and so that's the reshape. Actually, like you can you can kind of read this from NumPy and like kind of think what it does. Yeah, just provide a new shape, and the -1 would be just like anything that So one of the dimension required, you can put -1 there, mean that this one I don't care. You just fit in whatever you have to fit in there. But yeah, sometimes I just don't want to spend my spend energy in thinking of those. So yeah, so basically I think what it does is like a series is a one-dimensional array, and scikit-learn doesn't like it. It needs to be that. So it asks you to flip it and use reshape. So yeah, so it's just how NumPy works. And I hope I answer your questions. If not, you can ask me before I really cut myself off from the stream. And thank you so much for asking questions. I love receiving questions, so thank you, Colmat. I hope I pronounced your name correctly as well. So sometimes people have names that's super difficult to pronounce on stream, on Twitch. So yeah, that's it. And okay, so before I forget, I need to put I will have to put my I will have to put my repo link there so all of you can download next time. So yeah, so thank you so much. I will see you on Wednesday for Meet Me Pie. Bye.